Okay, we're live. Let me zoom in a bit. Is that readable? Looks readable. Maybe. There we go. One for good luck. What's wrong with my... Why? The monitor keeps crashing. I mean, not the monitor. I don't know where I see what I'm streaming. Okay. Then turn this machine on. Okay. So far, what I understand is virtual machine takes bytecode as input, creates a stack, and then puts and modifies things in the stack, and also keeps, what is it, keep the pointer to the top of the stack. Okay, that's just the test. Not sure I got much from it. Oh, okay. You just check if the results are what you would expect from 1 plus 2. vm.stacktop. I'm guessing that's a terminology when it comes to virtual machines. Okay, I mean, all of this could be done much simpler because I can just check the tag. Yeah. I mean, it's a small little fun fact that I found yesterday. It's not the same, but the error handling in Swift is quite similar to that of Zig. That's a useless fact, but in case, if you're ever wondered what error handling in Swift is like. When I saw exceptions, at first At first I thought they'd be like throw-in exceptions, but it's not the same. It's very similar to what we do in Zig. Okay, that's all I'm gonna say about that. The run VM tests function takes care of setting up and running each VM test case. Lex and parse the input, take the AST, pass it to the compiler. Yeah. Check the compiler for errors and then hand the bytecode over to the virtual machine. You should return new function should return a new instance of the virtual machine assigned to VM. This is where we get to the heart of each test case. We start the VM with a call to vm.run, and after making sure it ran without an error, we use a method called stackTop to get the object that's left sitting on top of the VM stack. We then pass that to test expected object to make sure that that this object matches what we expected in the expected field. Okay. Yeah. Okay. One is 1, 2 is 2, 1 plus 2 is, well, 2 for now, because we don't have the opcode for plus yet. So I guess all we do is we check that the stackTop has the right value. Yep, the input is, that is actually pretty neat. Yep. Ah, now I understand. Why he copied over parse and compile. Hey source code, this is me testing your speakers. Okay, you're welcome. Kind of makes sense why. You could just call the parser, I guess. Why have a parse method? Okay, anywho. Should I learn Zig? I should learn Zig. Is Zig fast? I don't think I can answer that question for you, Source Code. And the last bit, I'm not too sure. I haven't run any benchmarks. I mean, it's pretty fast. It's like C, so To be fair, I've never needed the performance yet. It worked on my embedded microcontrollers, so I guess it should be pretty good for everything else. Why do you think you should learn Zig? I don't think there's a should. I mean, there's a need, sorry. It's all noise, source code. Just follow your own, I don't know, intuitions. And I think, or follow your own curiosities. You'll probably stick with them for longer. I've been working on OpenCL, graphics card programming. I did Google it yesterday, or the day before yesterday, because I was like, what is OpenCL? And it's pretty cool. And trying out some SimD in Rust, but I'm not Rust savvy. I guess this is how you get Rust savvy. I think it shouldn't matter too much. Like if it runs where you want it to run and does the things you want it to do, you could do it in Rust, Zig, Odin, Swift, Go, or like whatever language for that matter. Guess it's really up to you. But so far, I do like Zig, I have to say. Well, if I go by page numbers, I'm like a sixth of the way there. I think there's a lot more to do, but I don't mind. But this is mostly the setup. Oh, I don't know what are you asking about Zig or the compiler? Mm-hmm. 1 plus 2, yeah. We only have a constant. The other two test cases with only the integers 1 and 2 as their input are sanity checks. They do not test separate functionality. Right. Okay, so make sure the first item is pushed onto the stack as well. Right. Okay, we have 2 KB of stack. Memory, yeah. VM is a why does it have constants and instructions? Type of stack is stack of SP -1. Okay, gotcha. Stack is a slice of object. Guess this could be an array with stack size. Yeah, I wonder why. Oh, probably because working with slice is easier. I'm guessing. Right. New takes bytecode as input and returns a virtual machine. Guess when you run, you need to translate the opcode into, or based on the opcode could define methods and then execute how do you know how many elements? Well, I guess it'd be part of the opcode's definition, maybe. Still not sure why it holds. Well, maybe because it's walking through the input. Maybe. Stack is pre-allocated to have stack size. Should be enough for us. SP is the stack pointer. Yep. Here's the convention we'll use for stack and SP. SP will always point to the next free slot in the stack. If there's one element on the stack located at index 0, the value of SP will be 1. Right, because it points to the next one. Knowing this, we define stack top. This returns All right, okay. Oh, it returns the object. That makes sense. Now, the only thing that's keeping us from running the tests is the missing run method of the VM. Yep. Code.opcode vm.instructions of IP. Okay, I guess instruction pointer. Yeah, that's kind of what I thought you would do. Then for each opcode, you take. Don't you need to go through the constants and add them to the stack first? That's the first part of the cycle, the fetch. We iterate through vm.instructions by incrementing the instruction pointer IP and fetch the current instruction. Forgot what the instruction looked like. Need the VM. Guess don't need these for now. Yeah, that's fine. Yeah, this is not necessary because I misunderstood. So it's adding constants. The instruction comes with an opcode and operand, which is the index of the constant. So I guess we got to grab this constant and add it, excuse me, to the stack. What is our list of constants considered to be the equivalent of stack? Because I see he's starting with the instructions. That's the first part of the cycle, the fetch. We iterate through vm.instructions by incrementing the instruction pointer IP and fetch the current instruction by directly accessing vm.instructions. Then we turn the byte into an opcode. How do we know? I guess if this opcode doesn't exist, you can just throw an error. Would it be a runtime error? Because by this point, compilation is already done. Interesting. Okay. Right, you grab the opcode. Oh, it's actually casting it. It's important that we do not use code.lookup here to get from a byte to an opcode. That would be far too slow. Costs time to move the byte around, look up the bytecode's definition. Excuse me. Return it and take it apart. I know this doesn't sound like my usual chant. We're here to learn, not to build the fastest thing ever. But we're in the hot path here. Everything we can get rid of, we should throw out. Using code.lookup here would be like putting a sleep statement in the loop. And in contrast to a generic method that wants to look up an opcode, like our mini disassembler in instructions.string, we have to encode our knowledge about the instructions into the VM's run method anyway. What was that again? In contrast to a generic method that wants to look up an opcode, we have to encode our knowledge about the instructions into the VM's run method. Can't just delegate the execution away. Treat every instruction the same. I understand a little bit, because this is execution. We don't want to unnecessarily slow things down. Right, I think this would be pretty simple. You switch opcode, and if it's op constant, which at this point is only one. You grab the next two operands, which are 16-bit version of the index, which is actually 32-bit. So you gotta do the opposite of what we did before. Yeah, and grab the constant based on the operand and then put it onto the stack. Okay, sounds not too bad at all. Yep, instruction pointer plus equals 2, because read uint16 reads 2 bytes. I guess it does read 2 bytes. Was it not code? Symbols. Uint. Can't remember what package was it. I thought it was code. Yeah, it's right here. Well, maybe not Unicode. Is it capital I? I don't remember now. I don't remember looking it up. Anywho, it reads the next 2 bytes because you need a 16-bit number from bytes. Interesting. So if you wanted to read a bigger number, okay, that's how that works. You decode the operands in the bytecode starting with byte positioned right after the opcode. And we use code.read uint16 I think because read operands underneath calls read uint16. Guess we can do a little bit better. Just do it Something burning. Weird. Something smells like burning. Hang on, I'll be right back. Okay, all good. There wasn't a fire. It's those mosquito things. Well, the thing that they spray for mosquitoes. Doesn't matter. Okay. Where was I? Right, okay. Slight detour. Okay. Increment the instruction pointer by the right amount. The number of bytes we read to decode the operands. Yeah. Excuse me. The result is that the next iteration of the loop starts with IP pointing to an opcode instead of an operand. Yep. Okay, so if you do this correctly, you should always be reading opcodes. What could go wrong? Still can't run the test because the compiler now tells us to use the declared but unused const index. What's the const index? Ah, here. Whoa. Every time. Why does the mic go to max? Okay. Yeah. Guess we just push that on. Constants of const index. Right. That's pretty cool. Stack Overflow. Yep, we check stack size. Actually, if you use an array, you don't even need to do that. Okay. Interesting. Nice. I think that was pretty straightforward. Not that bad at all. Guess I understand what I need to do. Oh, create VM. Parse through, not parse, iterate. Yeah, not iterate either. What's it called when you go through an array? Loop through instructions. And then add constants to stack. That's it. Easy. Guess we'll need standard, definitely. I'll use assert. To debug, yeah. Guess, do I need anything else? Not for now, anyways. Okay, our VM is gonna have constants, which is going to be slice of object dot object. Object dot sig. I think this came with the latest update of LSP on NeoVim, and I kind of like it. It's not part of my code. It tells me pretty cool. Okay, constants instructions. I think I just slice of bytes. Then we have the stack. Which is an array. I'll try making it an array. Is it slice of byte? Or 16, oops. I'm not too sure. const stack size. Excuse me, jeez, that was a bit loud. Stack size. Not sure. Oh fuck, it's not U16 because I only store object dot object. Okay. Then we need stack pointer, which will be the maximum value is that. Let's call it U32. Yeah, more than enough. And okay, the first thing we need to do is return a VM. Something in my eye. Getting the languages mixed up. It would need bytecode, which would be, it's not a pointer, I think, compiler dot bytecode, and compiler is right. Where do I use bytecode? Okay. And then it returns, learning from my previous mistakes, I'm going to return a pointer to a virtual machine. Guess then it needs a locator, which is mem. Mim. Is okay. Allocator dot create VM. Okay, nice. This can add a, and then VM is a pointer, so dot constants is bytecode dot constants, and then instructions will be bytecode dot instructions, and then stack is equal to the question is, do I need to, because it's an array, how to check? Can I declare an array without adding anything to it? Okay, I could just make it undefined for now. Don't know how to do this. Oh, I could do that. We just initialize it to if I make it undefined, can I add stuff to it later? I'll get back to this. Yes, this would be undefined. Stack is not optional, is it? It's not. SP will be 0. And I can return, yeah. Feel a sneeze coming. Okay. So that's done. Could go through instructions. We call it function run takes nothing. What would it return? I know, I can const stack, no, runtime error is, and I can have stack overflow. And it can return, I mean, it doesn't need to be called runtime error. I just like the sound of it. Or nothing. Okay. And I think this one doesn't need to be public. Function we'll call it push. Pointer to VM. Also take pointer to VM. We're defining methods, basically. And this can return. Can I just return stack overflow void? Guess it's undefined. Okay, if vm dot sp is greater than or equal to stack size, and runtime error dot stack overflow. Otherwise, just vm dot sp of vm dot stack This is the bit I'm not sure. So I either have to write it to the pointer itself, stack of vm.sp star equals, I guess we need an object to push. The question is, do I need that? Modify an array. I mean, if I follow the documentation, I'll check this later. Sure about this one. Okay. So that should push things onto the stack. Guess that these two are not needed. Is to get rid of that error. Okay, so all we gotta do is go through the instructions, find the opcode, and then add the constants to add it to what? hang on. Dot sp plus equals 1. Forgot to update the stack pointer. Okay, so let's just go through the instructions. Right. So instruction is an opcode. What is an opcode? Okay, so can I, is it called int to something? Get the tag, this tag name. Converts an enum value or union value. Not sure. Let's check enum. Int from enum. Converts an enum value into integer tag type. Okay, I think that will do. Oh no, we need the opposite. Enum from int. It's any type, so I can specify. Yeah. Const opcode is, this should be, okay, it's exported, so I can, oh no, I can just do compiler.opcode. What was that? What was it called? Capital O. I think it's in code is import code.zig. Dot opcode. Go to enum from int instruction. Okay, and now I can switch opcode and do dot op constant, then do something here, and then else is crash for now. Okay, I think we're getting somewhere. Converts an integer to an enum value. Can it add a? No. Okay. So now we need to read the next two instructions, which would be the index for the constant. Gonna do some as the emit method. To make I gotta do the opposite of this. I need to convert byte to a 16-bit number. It was easier to do the other way. Okay, I can do this. Let's say it's 0, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 0, 3, 4, 5, 6, 7, 8. So I'll have a 16-bit number, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. That'll be 1. Can I? Okay, what I can do is assign the first half to the 16-bit number. So this would look like 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 5, 6, 7, 8. And then I can left shift that 8 times, which would give me 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. Then I can and 1. So FF. Yeah. And that should give me no, not and. Oh, can I just do an OR with this 16-bit version? 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, that should give me the original number. Hope that makes sense. Next is going to be U16, which will be int cast of I need the index. Self dot instr no. Is it? Self dot instructions of I plus 1. Right, and then const index left shift equals. Can I do that? 8. Moves all bits to the left. Inserting new zeros at the least significant bit. Right. Okay. And then what do I gotta do? Oh yeah. Index or equals int cast of self dot instructions I plus 2. Can't do or equals. Oh, it's single. Invokes. Oh no. This might be something else. 0 1 0 1 0 0 1 1. Okay, no. But I'm not sure if that updates. I plus equals 2. I guess. So now vm dot self dot push self dot constants of const index. Guess I might have to, oops, encast this as well, because it needs to be a u size. I don't know. And I can do assert const index less than, yeah, less than self dot constants dot len. Should be like some safeguard against it. Now, if it all works, I don't know. Alright, I can write a test. Test virtual machine run. Gonna borrow some of the tests from compiler. Yeah, copy all of this. Allocator. Copy that too. Just modify that. And Lexer is import and I need parser and AST. Okay. What's this? Testing. Oh yeah. Const testing is standard dot testing. Okay. Input is going to be a string. Expected constants. Expected stack top. This will be expected so for instance, if it was 4 plus 5, I expect 5. Expected int, let's call it u64. What is it? Let me check. Object integer I64. Okay. Start with 1. Dot expected int 1 equals 1. I have 1 for 2. Then oops, 1, we'll do 1 plus 2, just like the book, and we still expect 2. Go program. Yeah, this is wrong. Should be compiler dot new compile. And then const VM is it's going to be new c dot, how did I get bytecode? C dot bytecode, bytecode comma allocator. Can this error? No. This can. Okay. Although it's not part of this test. Oh no, I don't need to check that. I think this is quite easy. Probably need a method. I think that's fine. To get top of stack function. Stack top. Yeah, we'll just return object dot object set no, don't need to assert anything. Return self dot stack pointer. Can it be null? Okay, let's see where it goes. Think I can get rid of all of this. Int object going to be object dot object dot integer test dot expected int. T. Teacher has value. What am I missing? Integer. Okay. Okay, now I can do try or stack top is equal to vm dot. I think I don't even need the variable. Try testing dot expect equal. Do I need to specify a type? No. Int object. Oops. Expected. Vm dot stack. Let's go top. Okay. Moment of truth. How many errors? Sick test. VM. Source. VM.zip. Compiler.zig. Why is that an error? Weird. Does it return? Huh. Returns an int. I can't remember. What was the point of this method? Instructions. Append instructions. Why am I returning index? New instruction is yep, okay. New instruction. I think that's singular. Oh no, there's not. Because there's an opcode as well. Okay, I don't think I need the index. That's the only place I use it. Yep. New is now marked up. New public. Compile is now marked up. Compile. No, it doesn't need to. Because it's not the stack. Okay, bytecode. Guess there's one more method. Yep, that's what I thought. No field named bytecode. Yep, because it's not bytecode, but also this needs to be public. It's a method. No field name stack top. Also a method. Let's go. At least something's happening. Nice. I didn't even expect the test to run. Okay. This could be one of the areas of problems. Standard debug dot print. Const index. I gotta run this in the test. Well, I can see what it is. 0. Maybe I can print. Hang on. Add VM. Standard debug. Print. Hang on. Did it not print because standard debug print Well, it should have crashed. Code, maybe instruction as well. And instruction is a U8. Yeah, number's fine. No, I'm not sure if it's because there are no instructions or it's my, hang on, sig test /source compiler. Okay, compiler's still fine. Standard debug print c dot. It's not public. I can print it here. VM dot instructions. The instructions are actually correct. What about constants? Okay, that's correct too. Expected 1 but found 0. Okay, let me check. I think the index is wrong. I can't. Oh no, I think that's fine. And I guess should also assert I guess it can't be negative because it's U16. Yeah, so it's fine. Okay. See what I'm doing. It should really just be 0. Then push self-dot constants of const index. Let me check push self-dot stack pointer is greater than stack size. It will return an error. Otherwise, I should print the stack, really. Well, nothing went wrong there, did it? That's crazy. I mean, it looks cool. What's wrong with my stack? It's an array, so fixed width, and I've allocated the virtual machine as well. I mean, to be fair, it doesn't really matter what the other values are. Maybe I can just print the first. Stack vm.sp, and then stack of vm.sp -1. I think I'm off by 1. What the fuck? It is correct. It's value 1, so it's my test. It's my stack top. There we go. So if self.sp is, does that mean I got it right the first time? Let's go. That's pretty cool. So only my test was wrong. Well, my first test was right. If self.sp is 0, return object dot object dot no. Oh, that should be null. And that should be null as well. Is that correct? Okay, maybe. It is empty. It has no fields. Integer overflow. Self.stack of self.sp minus 1. Which line is it? Whoa. Guess I should just run the test. See what happens. Okay, the stack is empty. Do I update? Yes, I do. Okay, so I didn't get it the first time. Why is the stack pointer 0? I think it's not 0. It's because it's a usize. I'm guessing. Nah, that wasn't it. Okay, so it should have. Am I calling run? Oh, well, that could be a problem because try vm dot run. That might help. Okay, so opcode. Why did it? Let me check enum from int. Don't think you need to save memory. Right, okay. Enum from int converts an integer into an enum value. When it says int, yeah, it's also any type. As opcode. What is the default type? No. How do I look up definition? Hang on, I've done it before. Oh no, I've done the opposite. Int from enum. Forty. Am I switching the enum correctly? Okay. Maybe. This seems redundant. Yep, that's what I thought. Because I know the opcode type. Hang on, what does enum from int? To an enum value. Yeah, that's what I thought. So does this need to be it doesn't feel right. Yep. Expected type found. Yeah, because up constant. Okay, let's see if Cloud can help. Can you see any obvious reasons as to why opcode is never reached? Instruction is 0. Maybe I pass it the enum as well. What? What does that have to do with anything? I mean, even then, it should just... Nah. That is not the problem. Might be, but not right now. It's going to unreachable instead of constant in the switch. Wait. Don't know why. My cats love the table. The problem is that the first instruction at index 0 is not actually opcode enum from end instruction. The instruction value I did pass the enum. Right, okay, I'm just gonna have to do it myself. Debug. Thing is, when you run it in a test, I don't think it prints the value. Instruction. And this could be any opcode. Instruction, comma, opcode. Yep, that's what I thought. Let me print. Whoa. Maybe before. Why does it not print the debug statements? That is strange. Yeah, I have saved it. That is weird. Not sure if this will work. Print. Yeah, can just print this. Ah, fuck. I just figured out what the problem is. Sometimes I should just read the error. It says unreachable else prong. Of course, because there's only one opcode at the moment. Okay, that's totally on me. Okay, there we go. That's funny. So I gotta keep our instruction index equals 0. Don't need that. Then don't need that. Need the comma either. instruction index. Plus 2 plus equals 2. Yep. Instruction index plus equals 1. What could go wrong? Must be const or com time. New size 32 is fine. Error union is ignored. Self dub push. Stack Overflow. Cannot dereference non-pointer type. I guess it is. Index out of bounds. Okay. Index 4, len 3. I guess here. There must be a better way. What did Cloud suggest before? I guess I could just do that. And then once there's nothing else. Really? Index starts at 0, 1, 2. Oh fuck. Yeah. I know what's happening. Because... yeah. This has to be a while instruction underscore index less than self dot instructions dot len. So its instruction is Instructions of instruction index. Two 012. Let's go. That actually work? That's why I don't. Get out of here. Oh, for fuck's sakes. Fucking cats decided to play on the. Every time. Okay. Guess we're back. Well, I mean, it was just as the stream ended, so it's fine. Almost. Okay, I guess for once we can end on a positive note. Remove all of this. Don't need that. Okay. I think the virtual machine has taken shape. That was pretty cool. Quite surprised I got it first time. VM taking shape. Alright, I quite enjoyed that one. That was a lot of fun. Alright. Okay. Thank you for hanging out. I'm gonna feed my cats before they break something else. And I shall see you back here tomorrow. Yeah, guess that's it. Hope you have a good day. And see ya.